trigonometry, a word derived from two Greek words. First part, trigon, second part, metry. Trigon means triangle, and metry really means measure. So we're talking about the measurement of triangle in terms of their angles and their sides. In this lesson, we'll be looking at Pythagoras Theorem. In the next lesson, the trig ratios, sine, cosine, and tangent ratios. And third lesson, the sine rule and cosine rule. Now, there are many mathematicians who have been credited for the development of trigonometry. These include Leonhard Euler and James Gregory, among many others, especially Pythagoras of Samos. The importance of trigonometry in everyday life. Now, according to Mathnasium, an online math educational website, the field emerged during the 3rd century BC from applications of geometry to astronomical studies. Now, trigonometry is used in everyday life. It is used by architects, surveyors, astronauts, physicists, engineers, and even crime scene investigators. The Pythagoras theorem describes the relationship between the lengths of the two short sides of a right angle triangle and the hypotenuse. Now, if we look at this right angle triangle here, we're seeing the two short sides. The two short sides meet at 90 degrees. They are perpendicular to each other. And opposite this 90 degrees angle is the side known as the hypotenuse. It is the longest side. It faces the 90-degree angle. The symbol for the right angle, as you see here, is a square. Now, as you see in this picture, a picture of Pythagoras, he is credited for the Pythagorean theorem. However, the concept of Pythagorean theorem has been used by the Babylonians and Indians long before Pythagoras. The Pythagorean theorem states that in any right angle triangle, the sum of the squares of the two shorter sides is equal to the square of the hypotenuse. So we're saying that if we square this short side and we square this short side and add them together, that result will be the same as if you would have just simply square the hypotenuse. Let's look into this further. So here we have this short side B and this short side A. Let's give them some measurement. Let's make B equal to 4 centimeters and A equal 3 centimeters. Now, if you construct this right angle triangle, you'll recognize that if you measure this third side, you'll actually get a length of 5 centimeters. Now, let's go back to what we were saying earlier. Should I turn this side into a square? So a 4 by 4 square. And this side here, let's turn it into a square, a 3 by 3 square. Let's do that and see what happens. What we're seeing here is that this side of 4 units, length by width, 4 by 4, will end up with 16 squares. That is, the area is 16 square centimeters. We said that this side is 3 centimeters. So if we turn it into a square, the area would be 9 square centimeters. In other words, 3 by 3 is 9, so we have 9 squares. And since we're talking about centimeters, the area being 9 centimeters square. So when we add these two sides, we end up with 25 squares, or 25 square centimeters. Now, when we look at this side here, which is 5 by 5, we actually get 25 squares, or 25 square centimeters. So the sum of the squares of the two short side is equal to the square of the hypotenuse. And that's where the theorem came from. Now, let's do some practice in identifying the hypotenuse. So this is the right angle where the two short sides GH and FH meet at 90 degrees. So they're the short sides, here and here. But opposite the right angle is the hypotenuse. So this is the hypotenuse. We're asked to state which side is the hypotenuse. Next, this is the right angle, and opposite the right angle we have the side LM or ML. So this is our hypotenuse. Now here we have the right angle again, and opposite the right angle we have the hypotenuse. The other two sides are the short sides. And here again we have this side, which is the hypotenuse, because opposite it is the hypotenuse. Opposite the right angle is the hypotenuse. again, we have the right angle. Opposite it is the hypotenuse. So A side AB is the hypotenuse. Again, we identify the right angle of 90 degrees. And so this side here, DC or CD, is the hypotenuse. Now we asked to calculate the length of the unmarked side. And so we want to identify the hypotenuse first of all, which is GF. So GF is our hypotenuse. And in the formula, C squared equals A squared plus B squared, the C is the hypotenuse. So the hypotenuse is this side GF, which is also representing C. Because remember we said that C is the hypotenuse. Now if I want to isolate the hypotenuse from the square, I will transpose this square over and it becomes what on the other side? That's correct, square root. So we end up having that C is equal to square root of A squared plus B squared. Remember, this is the theorem. We transpose the square to the other side and it becomes square root on the other side. So we're going to use this as our formula to find the hypotenuse. Now the hypotenuse is GF. So GF is really our C, which is equal to square root of A. We take the bigger one as A, so 4 squared plus the smaller one as our B, 3 squared. And so we get 16, which is 4 times 4 plus 9, which is the square root of 25. All right, so this is the square root of 25, and the square root of 25 is 5. Remember, we're dealing with centimeters, so our unit should be in centimeters. So GF is equal to 5 centimeters. In other words, C is equal to 5 centimeters. Next, again, we're using the formula. C squared equals A squared plus B squared. We identify the hypotenuse, which is LM, opposite the right angle of 90 degrees. And since we're finding that we're looking for the unmarked side, we don't have a measurement for this side, LM. So we're going to say LM is equal to the square root of, remember, in finding C, which is the hypotenuse, we can just simply transpose the square over as a square root. And so in finding the hypotenuse, it's always the square root of A squared plus B squared. So A squared plus B squared, let's put that in. And the hypotenuse, which is C, in this case LM, will be 12 squared plus 5 squared. And so we have 144, which is 12 times 12, 25, which is 5 times 5. And that's going to be 144 plus 25 is 169. And the square root of 169 is what? What number multiplied by itself? That gives us 169, and that's 13. So LM, which is actually our C value, in other words, our hypotenuse, is 13 centimeters. Let's look at another question. Again, we want to identify first off our hypotenuse. This is our hypotenuse opposite the 90 degrees angle. And since we're given the hypotenuse in this case, we're asked, therefore, to find KL, which is one of the shorter side. And how do we know this is one of the shorter side? Well, the two sides that form the 90 degrees angle are the short sides. So KL is a short side and LJ is a short side. Opposite the right angle is the hypotenuse, the longest side. So go back to the formula, which states that A squared plus B squared, which are the two short sides squared and added, is equal to the hypotenuse squared, the longest side squared. So I'm saying that if we want to find one of the short side, let's make A the short side. It doesn't matter if it's A or B, because in the order in which you add doesn't matter. So we're going to treat A as the side we're trying to find. So therefore, we're going to transpose this plus B squared over to the other side. Now, when we do that, based on changing the subject of the formula, you'll know that A squared is equal to C squared, and this B squared, this positive B squared goes over as a minus B squared, or the plus B squared goes over as a minus B squared. And so we have A squared equals C squared minus B squared. Now, we want to remove the square from A. And since A is the only term on this side, that is, A squared is the only term on this side, we can afford to move the square. So we're going to move the square over. And when we do that, it becomes a square root on this side. So A squared is equal to C squared minus B squared. When we transpose the square, we get A equal the square root of C squared minus B squared. And so now we can put in our information into this. So now you're seeing something here, that when you're finding the hypotenuse, you do what? You add. But when you're finding the shorter side, you do what? Subtract. As you can see here, we're subtracting. But when we're subtracting, we always want to put the hypotenuse first, as indicated by this formula that we have here, this formula that we derived from the original Pythagorean theorem. So square root of c squared, which being the hypotenuse squared, always put the bigger number first. So basically, if you look at these two measurements for the right angle triangle, just square the larger side first minus the square of the smaller side, and that's it. So the square root of the larger side squared minus the smaller side squared. As easy as that. So we have a equal 17 squared is 289, 15 squared is 225, and so now when we find a, we're going to get the square root of 289 minus 225, that's 64. The calculator can tell you that. What number squared give us 64? That's 8. 8 squared is 64. Therefore, the square root of 64 is 8, the reverse. So a is equal to 8. In other words, 8 times 8 gives us 64. So a, in other words, this side, which is KL really, KL, which is the same thing as a in our formula, because we said that we want to find the shorter side, a, and so KL is 8 centimeters. Now let's look at this other one. We're trying to find the unmarked side again. So identify the right angle first off, so you can identify the hypotenuse. And so this is our hypotenuse, the side that faces the 90 degrees angle. Right? Remember, this is actually 90 degrees, symbolized by a square. Okay, so this side is 37, which is the hypotenuse. So we're definitely not finding the hypotenuse. What side are we finding? The side that is unmarked, and that's NM or MN. Let's use alphabetical order. MN equal the square root of. Now, are we going to add or are we going to subtract? Yes, we're going to subtract. Why though? Because we're finding a shorter side. Very good. And we're going to have some number square there and some number square. Which number are we going to put first? The larger one, which is, yes, the hypotenuse. That's 37 squared minus the shorter side squared, which is 12 squared. And so we get the square root of 37 squared is 1369. 12 squared is 144, which is equal to, and that gives us 1225. And finding the square root of that is 35. In other words, 35 times 35 gives us 1225. So MN is equal to 35 centimeters. All right, so let's look at this one over here. That looks a little more complicated. And as you can see, we have two triangles. So this is one triangle over here, and this is another triangle here. Right? So here's a question. How are we going to find the lengths of the unmarked sides? So we have two sides that we don't know. We do not know the distance from C to D. Well, it's really the height of the triangle. And we also seen that we have a length here of D to B or B to D. Let's use alphabetical order. We do not know what side BD is. But what we can do, we can separate these two. Well, separate this triangle into two triangles. Triangle ACD. Of course, it's a sketch. Right angle here. ACD. And we also have this triangle over here, this one here, which is not drawn to scale, of course not. And this is B here. So we have triangle ACD as we draw that here. And we have triangle BCD. BCD, alphabetical order. Now let's put in our measurement what we have. So we have 15.6, we have 11.5, and we have 12.7. Can I use this triangle here, triangle BCD, to find any of these two sides, sides CD or side BD? Well, no, because we only have one side. And based on the theorem, let's look at this theorem. C squared equals A squared plus B squared. That's the Pythagorean theorem, which we use only for what? A right angle triangle, correct? Yes. So this is a right angle triangle, yes. But to find one side, we need to have the length of the other two sides. We only have one side in this. So we turn to this triangle over here. We are given two sides. And so since we're given two sides, we're now able to find the third side. But before we find the third side, which is CD, let's identify the right angle. And the right angle here is right here. And the hypotenuse is here as AC. So that means to find CD, put the square root, and we're going to have what? Some quantity squared minus another quantity squared. Why minus? Because we're finding a short side. The hypotenuse opposite the right angle is the longest side. And since we're finding a short side, we subtract. So we're going to look at these two numbers that we have, these two measurements, and put the biggest one first. 15.6, which is the hypotenuse squared, minus what? The other length, 15.5 squared. And CD will be equal to 15.6 squared, 243.36, minus 11.5 squared, and that is 132.25. And when we subtract these values, we get that CD is equal to the square root of 111.11, 111.11. Now finding the square root of 111.11, we get 10.54087, etc. Let's say we want one decimal place. So we're going to write from 1 right up to the 5, because the 5 is in the first decimal place, the first place after the point. So that's the first decimal place, the 5. I will check the very next digit. And we're going to check the very next digit because we want to see if we should add 1 to or should I say 0.1 to the 0.5. Should I add it? No, because the very next digit is actually less than a 5. So it's going to be 10.5. So CD is equal to 10.5 centimeters. So we have found CD, which is 10.5. It's 10.5 here as well, because same length, CD. So now we have for this triangle now, going back to this triangle here, triangle BCD, we have two sides now. So now we can afford to find this third side is DB. Let's find DB. Square root of, are we going to put a plus or a minus? Well, going back to this, we realize this is the right angle, and opposite right angle we have the hypotenuse. So the hypotenuse is given. Therefore, DB is a short side. And since it's a short side, we're going to subtract. And subtract the two measurements. Now, which one we put first? The hypotenuse of 12.7. So it's 12.7 squared minus. Now, I'm not going to exactly use the 10.5. I'm going to use up to 3 decimal places, because 10.5 is a rounded figure. I'm talking about here, 10.5. Let's go back to this. We have, it's actually 10.54087, etc. So I want to use up to 3 decimal places so I can get an accurate figure. So it's 10.54, and the 0, I'm going to add a 1 to it because of the next digit. So it's 10.54, not 0, but 1. All right. And so now I'm going to find the square root of 12.7 squared. Now, the thing is, you can put this entire figure underneath the square root in your calculator. In fact, you can put the square root of 12.7 squared minus 10.541 in your calculator if you desire. And then you just put the final answer right underneath it. But I'm going to just work out underneath the square root symbol. There should be a square here. So and that gives me 50.177. All right, to 3 decimal places. I want to find the square root of that. Now I just leave this answer in my calculator. I didn't round it off to 3 decimal places. I just leave the full answer that I got from this in my calculator, and then I press square root and press the answer key. So in the calculator, it looks like this. The answer I had previously was 50.177, etc. So I leave it at my calculator, press the square root symbol, then press the answer key. So it actually finds the square root of the result. of what I had underneath the square root symbol there. And I got 7.083595, etc. But let's say I want to 1 decimal place. Then I will go 7 point, check this. This is first decimal place. Check the very next digit to see if I should increase the 0 to 1. And because it's 5 or more, it falls in the category of 5 or more, I add 1 to the 0 and I get 1 here. So that's 7.1 centimeters. Okay, so this dB here is 7.1 centimeters.